All right, so let's begin with today's do now. Find the volume of the composite solid. Go ahead and pause the video and give it a try. All right, now let's compare your attempt to my solution. So what I'm hoping you noticed is that what you have here is a full sphere cut into two pieces. So we have two halves of a sphere, and we know that the volume of a sphere is equal to 4/3 pi r cubed. So this piece here and the other half over here have volume equal to 4/3 pi, and our radius here is half of 12, so 6 cubed, which is 4/3 pi times 216. 216 divided by 3 is 72, and then 72 times 4 is 288 pi. And this is in inches cubed. Now note that is just for the spheres. So we must also account for the cylinder volume. We know that the volume of the cylinder is given by pi r squared h. In this case, that is pi, our radius is still 6, so 6 squared, times h, which is 10. That is pi times 36 times 10, that is 360 pi inches cubed. Now to get the total volume or of the composite or object built up of the parts, we add the two numbers. So our volume for the total is going to be the sum. So 288 plus our 360, which in this case comes out to be, let's see, we get 8, 6 and 8 is 14, so 648, and sorry, both of these have pi cubic inches. And that's it. All right, so the focus of our lesson today, which I recommend you take some notes on, is on what are called polyhedron. Now, the figures we've been focusing on thus far, the cylinder, the cone, and the sphere, are mathematically not polyhedrons. Now, you might ask then, what is a polyhedron? And why aren't these three shapes polyhedrons? Well, the shapes on the right here are polyhedrons. Now, we say that a polyhedron is a shape that is made up of polygons. So if you look over here on the left, we see that the cylinder is made up of a circle, and so is the sphere, and so is the cone, and those shapes do not have polygon sides or bases. Whereas the prism and the pyramid are made up of polygons. The prism here we could see is made up of rectangles, and our pyramid is made up of a square and triangles. Now, when we talk about polyhedron, we say that a polyhedron is a solid that is bounded by polygons, and those polygons that bound it are called faces. So we see here that this particular polyhedron has several faces, one on top, one on bottom, two on the sides, and one on the front and the back. So this polyhedron has a total of 6 faces. An edge of a polyhedron is the line segment formed by the intersection of two faces. So for example, we see here an edge. There are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, in this case, edges. There are a total of 4 edges on the front, 4 edges along the center, and then 4 edges along the back. And then we're going to say that a vertex of a polyhedron is a point where 3 or more edges meet, as in a corner. We see that there are 1, 2, 3, 4, 5, 6, 7, 8 vertices. All right, in order to name a pyramid or a prism, we use the shape of the base to give it its name. So in particular, if we're looking at, say, this figure here in the image, we can see that the bases, the top and bottom here, are pentagons. So we can call this a pentagonal prism. Whereas over here on the left, we see that the base is a triangle and the sides are slanted upward. So we're going to call this a triangular pyramid. The main difference between, say, a pyramid and a prism is a prism, all of the sides, the height, are the same, right? So there's no slant, the height is perpendicular to the base. Whereas in a pyramid, the sides slant inward. All right, let's take a look at example 1. Tell whether each solid is a polyhedron. If it is, name the polyhedron. So if we look at number A, or letter A, we can see that it is in fact a polyhedron. And we can see that because if we look at the bases here, we can see that the bases are rectangles. So we can also see that none of the sides are slanted. So we're going to call this a rectangular prism. Now on part B, we can see that the base is a polygon, so it is a polyhedron. So first off, on A, yes, polyhedron, rectangular prism. B, also, yes, polyhedron. And this is what we're going to call, let's see how many sides it has. 1, 2, 3, 4, 5, 6. So we're going to call it a hexagonal pyramid. So hexagonal because it has 6 sides on the base, and pyramid because it slants up to a point. And then our last one is not a polyhedron, because if you look here, you see that its base is circular. So this one is not polyhedron. All right, now it's your turn to try. Tell whether the solid is a polyhedron. If it is, name the polyhedron. Compare your answers with your table mates. See if you agree. Make sure to pause the video to give it a try. Now imagine we take one of these three-dimensional prisms, like the ones shown here, and we take a plane and we slice it through that solid. The intersection of the plane and the solid is called a cross-section. In these 3 images here, we can see examples of cross-sections. In the first image, we can see a square cross-section. In the second, a rectangular cross-section. And then in the third, a triangular cross-section. Describe the shape formed by the intersection of the plane and the solid for each cross-section. On A, we can see that its cross-section has 6 sides. Its cross-section is thus a hexagon. On B, we can see that the cross-section is a triangle. In C, the cross-section is a rectangle. In D, we see a circle cross-section. In E, another circle cross-section. And in F, we see a trapezoidal cross-section. Try it. Describe the shape formed by the intersection of the plane and the solid. Compare your answers with your table mates and see if you agree. Pause the video to give it a try. All right, the last thing we're going to talk about today is what's called a solid of revolution. A solid of revolution is a 3-dimensional figure that is formed by rotating a 2-dimensional shape around an axis. The line around which the shape is rotated is referred to or called the axis of revolution. So for example, imagine I have this rectangle and I have this axis that I'm going to rotate it about. Imagine I spin that rectangle 3D out of the screen around that axis of symmetry or that axis of revolution. What happens is it will create a solid. When I rotate it all the way around, I can see that this rectangle forms a cylinder. Now, let's take a look at example 3. We want to sketch the solid produced by rotating the figure around the given axis. Now, one thing you must note is that when we rotate it, it will create symmetry on the other side. So we will get the same length and width on the other side. But also note that it will create a 3-dimensional figure. So in this case, we get a cylinder with a height of 9 and a radius of 4. On part B, we're going to take the triangle. And once again, it mirrors on the other side, but remember, it creates a 3-dimensional image. So if we look here, it creates a cone. So here we have a cone, and then on A, we have a cylinder. A cylinder with radius 4 and height 9, and a cone with a radius of 2 and a height of 5. All right, now it's your turn to try. Sketch the solid produced by rotating the figure around the given axes. Then identify and describe the solid. Go ahead, pause the video to give it a try. Compare your answers with your table mates. See if you agree. All right, last but not least, go ahead and jump onto Delta Math. You need to complete the three-dimensional figures practice assignment before 8 p.m. tonight. Try to finish it during class time to receive full credit. If you have any questions, feel free to ask the substitute or work together.